Alright, continuing our discussion on three variable systems, we're going to look at example 6 next. We're going to start diving into the applications. So our first example, application-wise, is Misha and Ben's combined SAT score was 2290. Ben and Ashley's combined score was 2530. Misha and Ashley's combined score was 2660. What we need to do is find each student's individual SAT score. And we have enough information to do that. So what I like to do in a problem like this is first assign variables. So maybe I let B equal Ben's score. Or just Ben, we can call it for now. A can equal Ashley's score, and M, Misha. So we can set up a system now. What we know is Ben and Misha, if we went B plus M, their score was 2290. We know Ben and Ashley, B plus A, that's 25, and I wrote up here something wrong. It should not be 2539, it should just be 2930, 2530. And that Misha and Ashley's score was 2660. So we've got our system now. I am going to go, first two. Let's take the first two. I'm going to set it up where I need B's, M's, and A's in both systems, both equations. So we're going to have B plus M, and we can add 0A. That's fine. Equals 2290. And then in the second one, we've got B plus, we can add 0M plus A equals 2530. Now I'm going to multiply, in fact I don't have to multiply anything, I'm just going to subtract my second row from my first one. My B's cancel out. I'm going to end up with M plus A, not M plus A, excuse me, M minus A, because I'm subtracting that A from 0A, equals 2290 minus 2530, negative 240. Now I've already got an equation with terms of M and A, so we can write that. M plus A equals 2660, and the A's are already opposites, so we're going to eliminate those. We're going to have 2M equals, if I combine these, we're going to get 2420. When we divide by 2, we're going to find Misha's score. So Misha's score, she got a 1210 on the SAT. Now we could take that and put it into our M plus A equals 2610. I'm going to do that on the next scene. So we know Misha got a 1210, and we have the equation Misha plus Ashley equals 2660. So we can go 1210 plus A equals 2660. If we subtract 1210 on both sides, we're going to find Ashley's score. So Ashley scored a 1450. Now with that, we either that amount or with Misha's score, we can go find Ben's score. We know Ben and Misha together scored a 2290. If we went B plus 1210, we can then find Ben's score. So if we subtract 1210 from 2290, we're going to find that Ben's score was a 1080. So for our answer, what we're going to do is we're going to write Misha she got a 1210. Ben got a 1080. And Ashley got a 1450. And there's our answer. I say let's for sure look at the next example. If we have time, we'll look at a third application, and then we'll call it good. So example 7, we have, in fact, I'm going to type this one out for you. Jada has 33 coins in her wallet. And those coins are all pennies, nickels, and quarters. What we also know from is that the total value of the coins is $3.41. If the number of quarters is 4 less than the number of pennies, we want to know how many of each coin does Jada have. So let's start by assigning some variables to what we've got going on here. Normally I would just use the letters of each of the coins, but some people don't like how my cues look. So what I'm going to do is I'm going to use X, Y, and Z. I'm going to let X equal the number of pennies. I'm going to let Y equal the number of nickels. And I'm going to let Z be the number of quarters. So there's some equations we can set up right away. We know that the number of pennies plus the number of nickels plus the number of quarters has to be 33 because that's how many coins Jada has. If we write this as 0.01x for 1 penny plus 0.05y for the amount a nickel is worth, and 0.25z for the amount a quarter is worth, we can set that equal to the total value of all the coins. Now we also know that the number of quarters is 4 less than the number of pennies. So we can say that z is equal to x minus 4. When solving this, since this last equation we wrote, z equals x minus 4, since that's in terms of z and x, that means I'm going to use the first two equations and I'm going to eliminate y. So I'm going to multiply the entire first equation by 0.05, and then I'm going to rewrite everything. So I'm going to have 0.05x plus 0.05y plus 0.05z equals 1.65. And then I can rewrite my original second equation, 0.01x plus 0.05y plus 0.25z equals 341. So I'm going to just subtract my second equation. I'm going to end up with getting the y terms gone. I have 0.04x. When I subtract 0.25 from 0.05, I'm going to end up with a minus 0.20. Z equals, when I subtract 3.41 from 1.65, I get a negative 1.76. So now what we can do, I think, let's use substitution to solve this for x, because we know z is equal to x minus 4. So on my next page, I'm going to do that. I'm going to substitute x minus 4 into z. So we're going to have 0.04x minus 0.20 times x minus 4 equals negative 1.76. So now we can distribute this negative 0.20 to x minus 4. We're going to end up with 0.04x minus 0.20x plus 0.8 equals negative 1.76. If we combine the x terms, we're going to get negative 0.16x plus 0.8 equals negative 1.76. Subtracting 0.8, we're going to get negative 0.16x equals negative 2.55, and if we divide that by negative, correction before we do any division, this should be 0.56. Let me clean that up so you can read that. Negative 2.56. We're going to divide that then by negative 0.16. And we're going to get x equals 16. So we're going to have 16 pennies. Which now we can figure out the number of quarters, because we know that the number of quarters is equal to the number of pennies minus 4. So 16 minus 4 means we're going to have 12 quarters. So if we've got 12 quarters and 16 pennies, we know that the number of pennies plus the number of nickels plus the number of quarters is equal to 33. If we know 16 is x, we don't know y, and we know we've got 12 quarters, if we subtract, or we can add 16 and 12 first, y would plus 28 would be 33. Subtract 28, we're going to get y, the number of nickels, is equal to 5. So we know we've got 12 quarters, 16 pennies, and 5 nickels. And I think you've heard me ramble on enough about 3-variable systems. We're going to actually leave the remainder of our examples, that's 8, 9, 10, and 11, we're just going to leave them blank.